welcome you all for today's session, that is embedded memory. So in this session we are going to discuss about the different types of memories, like in memory hierarchy, cache memory, and different types of cache mappings, cache impact on system performance, dynamic memory, and different types of dynamic RAMs, as well as immediately if memory we remember that RAM ROM, right, like static RAM, static ROM, dynamic RAM, dynamic ROM. So all are types of memory, right? So in embedded, like hierarchy objective is to use inexpensive. The first memory is the best memory. It is expensive, and the slow memory stores the entire program and it makes delay, right? So this is too expensive. Fast memory stores copy of likely accessed parts of larger memory and which can be multiple levels of cache. So this is the memory hierarchy: process, registers, cache, main memory, tape, disk. Okay, so first tape, then disk, main memory, cache, registers, process. This is the hierarchy of a memory. So cache, usually it is designed with SRAM, the most but more expensive than DRAM, usually in same chip as processor, which can be smaller than off-chip main memory, and it requires for main memory access. It may be read or write process. First it checks the cache for copy, then quick access, several cache design choices like cache mapping, replacement policies, and write techniques. Okay, so here mapping, it is necessary as there are far fewer number of available cache addresses in memory. So address contents in cache, there are types like basic techniques, direct mapping, fully associative mapping, and caches partitioned into indivisible blocks or lines of adjacent memory addresses, usually 4 or 8 addresses per line. So mapping here, the memory address is divided into two fields which contains address and bits of determined by cache sizes. So the registered with stored in cache at address indicated by index will match and also will check the valid bit. Here two types, one is valid bit and offset. Valid bit is which indicates whether the data in slot has been loaded from memory, and offset, it is used to find particular word in cache line. So this is the direct mapping of an embedded memory, like tag, index, and offset. So with the data output and valid, right? V represents valid, and T represents tag, and D represents your data. So associative memory, so it is a complete main memory address stored in each cache addresses. Parallelly, addresses stored in cache simultaneously compared with desired address, valid bit, and offset, same as direct mapping. So it is a fully associative mapping. It is a structure of fully associative mapping, right? Next, set associative mapping. It compromises between direct mapping and fully associative mapping. The index same as indirect mapping. So this is the structure of set associative mapping. So it is 2-way, 4-way, and 8-way, which is common, right? So the cache replacement policy. This is a technique for choosing which block to replace. When fully associative cache is full, when set associative cache line is full, direct mapped cache has no choice. So LRU FIFO. LRU means least recently used, which replace block not accessed for longest time, and FIFO is first in first out, which push block onto queue when accessed. Choose block to replace by popping queue. So the cache write technique is write through it and write back. These are the two techniques in cache write techniques. And cache impact on system performance is most important parameters in terms of performance: total size of cache, total number of data bytes cache can hold, and tag, valid, and other housekeeping bits not included in total, then degree of associatively, data block size. So this is the largest cache achieve lower miss rates but higher access cost. This is an example for that type of caches. And this is the cache performance trade-offs. That is our cache performance, how it shows associatively, changes set associatively. And these are the types of advanced RAM, which has the limitations of DRAMs like in capacity and low cost. And FPM DRAM, that is first page mode, EDO DRAM, extended data out, and SDRAM and ESDRAM or DRAM. These are the types of advanced RAMs. Basic RAMs, so bus multiplexed between row and column components, which refers circuitry disabled during read or write operations. These are the purpose of basic DRAM. And this is the basic dynamic RAM structure, which consists of buffer, address, out buffer, in buffer data, out buffer data, circuit refreshing, call decoders, sense amplifiers, RAM row and column decoders, and it has a bit storage array here. Array means we know first in first out, which consists row and column, like column decoder and row decoder. This is the structure of the basic dynamic RAM. Okay, so the embedded memory here, DRAM, that is FPM DRAM, which consists of 3 words read consecutively by sending column address for each extra cycle, eliminated on each read write of words from the same column. Okay, the timing diagram in FPM DRAM, this is the timing diagram which shows the FPM DRAM. And the extended data out, the second one, EDO DRAM, this is the timing diagram of EDO DRAM, which is the improvement of FPM RAM, and it is a latch before output buffer. And next, ESDRAM, it is a synchronous and enhanced synchronous DRAM. ES represents our enhanced synchronous, and this is the timing diagram in SD or AM, that is a latch that latches data on active edge of clock. And RAM bus DRAM, that is OR DRAM, most of a bus interface architecture than DRAM architecture. It is capable of very high throughput. And DRAM, it is an integration problem which is easily integrated on same chip as processor, and the goal of DRAM designers is to create capacitor cells to retain stored information and integration process beginning to appear. Next, the last one is memory management unit, MMU. It is the duties of MMU is it handles DRAM refresh, bus interface and arbitration, takes care of memory sharing among multiple processors, and modern CPUs often come with MMU built in, and single purpose processors can also be used. Yes, thank you all.